Welcome to qnawire.
For problem 38, we're given a converging lens with a focal length of 12 centimeters, and we're told that a virtual image forms to the right of the lens at a distance of 17 centimeters away. Since the image is virtual, we know right away that the image distance is going to be negative. So I right away put a negative sign in front of the image distance. We're told that the height of the image y prime is 8 millimeters, and we're asked to find the object distance and height, which are labeled by s and y respectively. And we're asked if the image is erect or inverted, if the object and the image are on the same side of the lens, and also we're required to draw a ray diagram. So in order to find s, the object distance, let's use equation 34.16. Okay, because we have enough information to determine s. So s prime and f, these are both known. They're given to us in the statement of the problem. And so we can very simply solve for s. So 1 over s is 1 over f minus 1 over s prime. And then I can put these over a common denominator and then flip everything by just taking the reciprocal. And then I get s is equal to s prime f divided by s prime minus f. S prime is negative 17 centimeters. F is 12 centimeters. So in the numerator we have the product, in the denominator we have the difference between S and F. And this leaves me with the value of S of 7 centimeters. Okay, so that takes care of the object distance. Now we need to find the height of the object. So we can use equation 34.17. So there we have a new quantity, magnification is equal to the object height, the image height rather, over the object height. But we don't know m, however we do know y primed, and we don't know y, so this doesn't seem like it's enough to give me what I need. But there's a second part to this equation where the magnification is also equal to negative of the image distance over the object distance. S and S prime are both known, therefore I can readily determine m. Once I know m, I can rearrange things in this equation to solve for y. So from here, I can find m. So remember, s is negative 17 centimeters. S prime, sorry, and s we just found is 7 centimeters. And that gives me 3.25. Sorry, that gives me not 3.25. And I urge you to also check my arithmetic as I go along. Just plug in the numbers yourself. Sometimes I do make mistakes with these things. That is 2.43. And since m is positive, so m is positive, that means that the image is erect. Okay, so we know M. Now we can use this portion of the equation if I rearrange a little bit. So if I multiply both sides by y and then divide by m, then I have y is equal to y primed over m. Y primed I know. Y primed is 8 millimeters. And m, I know, m is 2.43. Therefore, the object height is 3.29 millimeters. Again, I will urge you to verify all the numbers for yourself. Now we will draw the ray diagram on the next page. So here we have the optic axis and a converging lens. Let's say that's the middle, and this is the focal length on one side and on the other side. And from the problem, we found that the focal length is about 12 centimeters and the object was about 7 centimeters. So somewhere midway is the object. So let me pick a different color. So let's suppose that's our object. And now what we'll do is take some rays that are going out. So we have one that's going through the center like this. It's supposed to be a straight line. And then another that's as if it's coming from this focal point here, and then this ray will go parallel to the optic axis. And if I extend that backwards, then I can draw my virtual image here, like so. There could, of course, be another ray that is, in fact, going parallel to the optic axis, and then that will go through the other focal point, and that should intersect these lines, but I haven't drawn things too right, so I may have trouble doing that one. But the intersection of these two lines is enough to give me the virtual image. So this is S, and this is S prime. And the distance from here to here is F.